Business applications of optimization. So imagine you're in business and you want to stick around for the long term. You don't want your business to be non-viable all of a sudden. You want to look at things like maximizing profits. There's a competitive world out there. You want your business to last. So maximize profits and minimize the costs involved in producing whatever it is that you produce, whether it's videos or you're into manufacturing or something else. Let's make sure we understand some basic terms first before we get going. Revenue is an important one. So you might have heard of this word. You might already know what it means. Revenue is basically the money coming in. Now that's not the same as profit. Money coming in when you sell stuff. But it's not the same as the profit. We'll get to the profit in a minute. Revenue is the amount of money coming in. Now we can use that as a function, and if you're selling n units, where n is a variable, it would be called R of n. So R of n is the function if we're basing it on the number of units sold. So n is the number of units, well, let's say produced, units produced, and we're assuming the units produced are the units sold. Okay, so that's an important assumption. So units, we're assuming units produced equals units sold. Units produced equals units sold. That doesn't always happen in the real world, but we're keeping it simple at this stage. Okay, there's a couple of assumptions in these basic models. So n is a number of units produced / sold, same thing in this case. Alright, and we're going to define a small p. P is the price per unit, the market price. It's how much people pay for it. Okay, so getting back to this R of n, we can actually come up with an equation for R of n, the revenue function. It's the price per unit times the number of units you sell or produce. So that would be little p times little n, lowercase p times lowercase n. So that's important. So revenue function is Pn. So that's a function according to number of units sold, P multiplied by N will give you that. Now profit is not the same as revenue, although it is related to the revenue. The profit, let's call a profit function according to the number of units sold is P of N. Now that would be your revenue, so yes, it does depend on how much money is coming in, minus, of course in the real world there are costs to do with the production. I'm going to call that cost function C of N. So C of N, the cost or costs of production, or the collective cost of producing these items. So it's the cost of producing n items. So that's an important thing to note as well. So we can simplify that equation slightly, so that it would be P times N minus C of N if we're given C of N, or if we can work out C of N. You'll get tasks to do which might be based on a given C of N, or you have to come up with your own. This video will be mainly associated with when you're provided with an equation for C of N. Later on we'll do stuff where you've got to create that equation yourself based on given information. Now before we said we're assuming the units produced equals the units sold, we need to also assume that little p is a constant. Now that doesn't always happen in the real world either, but in this simple example we do. So the number of units you sell does not impact on the price. Okay, so p is constant, it's independent of n. Alright, it's independent of n, so it's not affected by the number of units sold. Now in the real world, of course, with mass production, there's ways of making things cheaper, and also of competition, it drives down the price as well. So p can change, of course, but we're going to keep p as a constant. Okay, so the number of sales does not affect the market price, and the competition and economic conditions does not affect the market price. Obviously you can see how that might affect the profit equation there mathematically. Let's look at an example. A fledgling manufacturing operation can sell all of its production at a price of $8 per item. The production cost for producing n items per week in dollars is given by that equation there, that wacky looking equation. So C of n is a cubic equation. Note also the use of scientific notation for the coefficient of n cubed. What we've got to do is determine what should the weekly production target be in order to maximize profit. So we've got dollars and weeks are our units, as well as number of items. So profits, we want to maximize profits. Maximize means optimize, and we're going through our known optimization techniques using calculus. Profit is what we're looking at in this question. Some questions don't look at profit, they might look at cost or other quantities. We're looking at profit. So let's get our profit equation written down. So P of n equals R of n minus C of n. And R of n it's $8 per item, so it's 8n. So that means we've got 8n minus, now algebraically, be careful, we're minusing all of C of n, which is 100,000 plus 8n minus 0.156 n squared plus 2 by 10 to the negative 6, 2 millionths, n cubed. Alright, so it's 8 minus everything in brackets. I often see students algebraically get these sort of things wrong. So everything in the brackets there, sign has changed to the opposite sign on account of being subtracted off. Now we can see that these two guys will cancel. Okay, they'll knock each other out. So what we've got then, look at all the signs. That 100,000 is positive. It'll now be negative. So it'll be negative 100,000. The minus 0.0156 is plus. N squared minus 2 by 10 to the negative 6n cubed. Okie dokes. So we have P of n there. Now of course this video assumes that you're well versed in optimization. So let's find, I won't explain those steps really. This is assuming you already understand and have done optimization. So we need to find the derivative. I'm going to call it P dash of n, and we've got here 0.0312 n minus 6 by 10 to the negative 6n squared. Stationary point, so when the derivative is equal to 0, so we set that equal to 0. So 0 equals 0.0312, etc. Alright, so rearranging and solving now. So we've got 6 by 10 to the negative 6 n squared equals 0.0312n. Actually, no, I don't want to do that. I want to factorize. I've just spotted what I need to do. Both of these terms have a factor of n. So we take that factor out, times 10 to the negative 6. Let me just make sure that's clear. And that leaves a factor of n inside there. So null factor law. That you're familiar with. So one of the solutions to that is n equals 0. And that's an interesting solution. More about that in a minute. And we look at the other solution is when I can explain that a bit more. So null factor law is two things multiplied together equals 0. The first thing equals 0. The second thing equals 0. The second thing is this item here, this term. And so it's when that equals 0. So 0.0312 minus 6 by 10 to the negative 6 n equals 0. So 6 by 10 to the negative 6 n equals 0.0312. So n is 0.0312 divided by 6 by 10 to the negative 6. Bang, that's 5,200 units. So we have two mathematical solutions there. We have 0 and 5,200 units. Now, bit of reasoning here would not go astray. What's with the n equals 0? Well, you could test that and you'll find that it's a minimum. But using just direct reasoning, that's the minimum. So stationary point will give you maxes and mins. That's a minimum. It's pretty obvious, so I'm not going to even test that one. Okay, because n either side anyway, when you use the first derivative test or even the second one, the first derivative test, if you try and go either side of that stationary point, what are you going to do? Go less than 0? You can't have negative values for n. So it'll run into strife anyway. Direct reasoning is best there when you try and find the nature of that turning point. Okay, so that is obviously not the answer when we have 0 units. Okay, so and on top of that we can inspect the P of n equation here anyway, and when we substitute 0 in there, you can see that really it's going to be negative 100,000. So you're going to lose 100 grand in 1 week by not producing anything if you're still paying for the costs. Of course, that wouldn't be right anyway, but maybe it would be. Maybe that's those fixed costs of production. So you're not going to lose, you're not going to gain anything. So that's definitely not the answer. So pursuing 5,200. So the nature of the stationary point, where we can use either the first or second derivative test. So I'm just going to use the first derivative test because it's not the most efficient, but it is a safer bet, just to keep the video short and sweet and easy to understand. So I'm going to go either side of the turning point. You should be familiar with that, and let's have a look. So into P dash we put in the two values that are, two values, one's just before, one's just after the stationary point. That gives us the nature of our stationary point, and it's a max. That's what we wanted. So 5,200 units is, let's answer the question, what is it? What is the profit? So mathematically we're finding P of 5,200, so we enter it into our equation and crunch that, and bang, hey presto, there it is. Okay, so that was that P of n equation from before, and crunching that, hit execute, there's our answer. So when we sell 5,200 items, we can get a maximum profit of $40,608. And based on those assumptions we mentioned in the video, that P doesn't change. It's not affected by the number of units sold, which we've got up there, and also that the number of units produced is the number of units sold. Fun!